All right, in this video I'm going to talk about how to determine if a data set has any outliers. One reason you might be calculating outliers or determining if there are outliers is because you're going to be making a box and whisker plot, or just box plot maybe is what you call it. And to do so, outliers would be identified with either an asterisk or a point or something like that, instead of the whisker going all the way to the minimum. So one thing you would do is you would calculate or determine your 5-number summary for the data set. Again, this is just about outliers, so I'm going to just start off already having the minimum, Q1, median, Q3, and maximum determined. Box plots were invented or created by someone named Tukey, and he is the person who came up with the formula for determining if a data set has any outliers. And it relies on using the interquartile range. Interquartile range being Q3 minus Q1, or 50%, the range of the middle 50% of the data. So Q1 is our marker for the 25th percentile, Q3 the marker for the 75th percentile. So how spread out is the middle 50%? And the formula he developed, or he used, was anything that was more than 1.5 times the IQR above Q3, or anything that was more than 1.5 times the IQR below Q1 would be an outlier. And so this calculation of Q3 plus 1.5 times the IQR gives us what's called the upper fence. Anything greater than the upper fence is an outlier. And Q1 minus 1.5 times the IQR gives us what's called the lower fence. So anything smaller than that would be an outlier. For this particular data set, which is the number of walks in the last 12 years of Frank Thomas's career, does it have any outliers? Well, Q3 is 104.5, Q1 is 71, so we have an interquartile range of 33.5. So 1.5 times that. If it's more than 1.5 times that, plus 104.5, we have an outlier. So any data item that is more than 154.75 is an outlier. And it doesn't appear that any data items are greater than 104.75. And for the lower fence, so we have no high outliers, Q1 minus 1.5 times IQR, and we get 71 minus 1.5 times 33.5, we get 20.75. So any data items in our set that are less than 20.75 would be an outlier. And 16 would be an outlier, and so would 10. So for the box plot, it would look like this. Q1 is the start of the box, Q3 is the end of the box, we mark the median. We had no high outliers, so we just marked the whisker from Q3 up to the maximum value. Marked outlier for 10 and an outlier for 16. And a mistake that I've seen some students make is to draw the whisker all the way to the lower fence. Well, that would give a false impression of the data. It would kind of make it seem like this extends all the way and there's data items all the way in this range. Well, there's not. If we look back at the data, the only value that is in the first quartile that's not an outlier, that's an outlier, that's less than 71, so that's in that first quartile, quarter of the data, and 10. So that one, 64, we indicate, or we draw the whisker all the way up to that next lowest value that wasn't an outlier, not all the way to where the lower fence would go. All right, so that's how to find an outlier for a given data set. What I'm thinking that you might want to consider here would be another data set, or another way the data could be presented. So here we have the salaries of the 2012 White Sox. There's some summary statistics, the minimum, Q1, median, Q3, and the maximum. And so does this data set have any outliers? And how would you use what I've just shown you here to determine that? So does it have any outliers? And how would you justify your answer? I'd be interested in seeing some of you post a video response to that question.